Okay, very good afternoon, everyone. Today our webinar is on mathematical modeling with MATLAB. We'll see lots of things that how we can choose the best mathematical models and plus regression, linear or non-linear kind of regression. So myself, Akhilesh Kumar, Assistant Manager, Application Engineer for the Design Tech System Limited. Mr. M. Jaffer, he is a National Manager for MathWorks products. So he is helping and coordinating us to provide such kind of webinars. And Mr. Nipun Sharma, he is a Senior Executive Sales. So he is a sales representative in your region. If you have any query or questions related to sales, you can contact Mr. Nipun Pandey for that. Okay. Hope my screen is visible for everyone and my voice is also audible for everyone. So this is our agenda for today. What is mathematical modeling and regression. Second, we are going to see what is difference between linear and non-linear system, regression and mathematical equation. So when you are going to create a mathematical model of any system, it is very important to know that what is a linear and non-linear system, what is regression, linear regression, non-linear regression, and mathematical equation. If I require a linear mathematical equation or non-linear mathematical equation, and we have to know the differences also among them. Okay. Further, in MATLAB we are going to use stepwise linear regression, that is used to automate to choose the best fit. Means what is the best equation if you have assigned some multiple equations, which will be a best equation within that. Second thing, we are going to use two more algorithm in MATLAB for mathematical model, that is RIS and Lasso regression. It is these both are used to identify predictors, that which predictors are required for your model and which are redundant. Okay. If you have a time, then further we will see overview on optimization and global optimization with MATLAB also. So first of all, what is a mathematical model? A mathematical model is a description of a system using mathematical concepts and language. The process of developing a mathematical model is termed mathematical modeling. Let's say that you have some kind of systems. Your systems can be your mobile, your system can be any plant, it can be chemical plant, or it can be some kind of manufacturing plant for vehicles or any kind of thing. That is a system. And if you want to do mathematical analysis on it, or if you want to create a mathematical model for that, the process which we do to create a mathematical model for your system, that is called mathematical modeling. In other way, you can say models are what is model? Model describe or believes about how the world functions. In mathematical modeling, we translate those beliefs into the language of mathematics, that is called mathematical model. Okay. So what is difference between machine learning and mathematical modeling? I will like to tell you that also, because next session is on the machine learning. So mathematical model are kind of static model that represent a natural real phenomenon in mathematical form. The models once formulated, so remember, the model once formulated does not necessitate to change the form after they are formed. It means once you created a mathematical equation, and if you don't want to modify that mathematical equation, then you can go for the mathematical modeling. Vice versa is machine learning. Machine learning or deep learning models are enough flexible to change as per arrival of new data, as they can incorporate new and emerging patterns and trends. What it means, that once you create a machine learning model or deep learning model, let's say new trends are coming, new data are coming, new requirements are coming. Based on that, your machine learning model will be updated. But in the case of mathematical model, it is not possible. You have to create again a new mathematical model if new data are coming, new trends are coming, new demands are coming. Okay. So first of all, we have to understand first of all what is linear and non-linear system, what is linear and non-linear regression, what is a linear and non-linear mathematical model. Both are related with each other, and all these three things are independent also with each other. So first of all, let me show you one simple how to explain that what is a system. First of all, let's say that this is a system. Transfer function is, let's say that is a gx. We are giving some input to this system and we are getting the output. So what is a linear system? If input of your system is to, or you may say, if your system is totally dependent on the input which you are giving, then it is called the linear system. Just wait a minute. My screen is visible for everyone. Anyone can write in a chat box that my voice is visible and screen is visible or not.
Yes, yes, yes.
Okay, thank you. Okay, here we were. Now let's see that what is a non-linear system. If your system is not only dependent on input which you are providing, it requires some other factors also. Let's say that I have a system, it depends not only input, it depends on humid also, it depends on temperature also, or maybe it depends on the pressure, atmospheric pressure which we are giving on it. So if you consider other factors also, then system will be a non-linear system. And to represent a non-linear system as a mathematical model is very complicated. So let me give you one example here. Let's say I have one system here, fx is equal to gx, simply. So in this case you see that our input is totally dependent, our output is totally dependent on the input. Our system is totally dependent on the input. We are giving the x, we are getting the gx. That is a linear system. If I am talking about non-linear system, okay, we will have this gx plus we will have some other factors also. Let's say it is hx. So hx can be anything. It can be dependent on the humid, it can be dependent on the heat of your system, it can be dependent on some other factors also. So when you are going to create a mathematical equation of your system, and if your system is not linear, you have to consider these other factors also. Let's say mobile, if I'm talking about mobile is non-linear system. If any system is purely non-linear, it can work till your life. Today I purchase a mobile, after 1 year and 2 years some degradation occurs there, and further we will not able to use that mobile. Maybe there will be battery issues, some other issues. Why? Because there are some kind of non-linearities, some degradations are occurring because of some other factors. Okay. Now, what is linear regression? I am going to write two equation here. Y is equal to ax. Another equation I am going to write here. Y is equal to a square x. And one thing more here I am going to add here. That is plus b x square. And here also I am going to add one more sub function here. b y. So first which you see, a and b in y, the first equation, this one, a and b are linearly added. That are model parameters, a and b. If model parameters, or you may say regression coefficients, are linearly added, or you may say if they are linearly dependent, then it is called linear regression. Okay. Second equation you see here is a square x plus by. What is here model parameter? A. It is square. And second, what is model parameter? That is b. That is also called regression coefficient. They are non-linearly added. A square and b. They are how they are related? Non-linearly. So this is a non-linear regression. And first equation which you see, that is a linear regression. About mathematical equations, you know that what is linear and what is non-linear, right? So if I am saying my system is linear, so it is not necessary that my regression will be also linear. If my system is linear or non-linear, then my regression can be a linear and non-linear both. We will discuss later that what is regression, which I am talking about. Okay, if regression is linear or non-linear, then my mathematical model can be also linear and non-linear. It's not like that if my system is linear, the regression will be also linear and mathematical equation will be also linear. Okay, I'm switching here in PPT. So what is regression? In statistical modeling, regression analysis is a set of statistical process for estimating the relationship between a dependent variable, that is the outcome, and one or more independent variable that are called predictors. Means we make a relationship between dependent variables, that will be one, and independent variable, that will be one or more than one. That is called a regression analysis. Okay.
Mr. Akhilesh,
Yes, please.
कुछ पार्टिसिपेंट्स आ रहा है कि उनको वीडियो और जो है ऑडियो दोनों विजिबल भी नहीं है और ऑडियो भी नहीं आ रहा है, तो एक बार थोड़ा सा चेक कर लीजिए.
Okay.
दो
Can
मिनट
I
के लिए.
share a YouTube link, sir? That there will be no issue if they watch YouTube, if they want. I mean, maybe there will be internet issue for that.
After the presentation.
No, just right now. If you are in.
Okay, please share.
I am sharing in the group. Okay, sir. So they
Okay,
can watch on
share-
YouTube
share
and they will not face any issue. Should I?
Okay, share Nipun to forward me. ठीक है. Okay.
Okay. Just 1 minute. Just hold a minute. I am sending you Nipun and Nipun will forward.
Okay.
Okay. Just 1 minute, sir. Just 1 minute, sir. Just hold a minute. Okay, we will start now. Nipul will share the YouTube link. Okay. So I was talking. Now it is clear. Voice participants. Is it
We
okay?
are hearing it, but some participants are not hear you. Please forward the link also in the chat room.
Sure. Just wait a minute. So you can watch on YouTube live also. Hope that there will be no issue if you watch on YouTube. I shared in a group as well. So I was talking that what is regression. Basically, when we make a relationship between independent and dependent variables, that is called a regression. Basically, so your independent variables can be one or more than one, and your dependent variable will be only one in this case if you are using regression analysis. Okay, so these are some examples which you see. These graphs, these are linear equation, and that is a non-linear equation for that. Okay, so again I am telling, your system can be linear or non-linear. Based on that, your regression also can be linear and non-linear. They are not dependent actually. And if regression is linear, it doesn't mean that your mathematical equation will be also linear. It can be a linear and non-linear as well. So we talked about this. Next, linear and non-linear regression. Already we discussed. See this first graph. This is a linear regression, right? Here, what are model parameters A1 and A2? Both are linearly added. Second graph which you see, that is non-linear because A2 is cube and A1 is just a constant, some parameters. So here A2 cube and A1 are non-linearly added. So that's why it is a non-linear regressions. So check whether if it is a linear model or non-linear. So first one which you see here is a 5 square. The 5 is what? That is a model parameter. 5 square plus 6 square x plus 6. That is a non-linear regression, and my equation is also, mathematical model is also non-linear in this case. Now see this, in this case 10 is linear, right? and 15 is also a regression coefficients. Both are added linearly. So in this case, regression is also linear and my equation is also linear, right? Third one you see here, regression coefficient or model parameter is 10 square and 15. Both are non-linearly added, right? So in this case, regression is non-linear but mathematical equation is linear. Okay. Last one. Here you see 5 and 6 are regression coefficients that are also called model parameters. Both are linearly added. So regression is linear and my equation is non-linear because exponential plus sin x both are non-linear. So equations are non-linear. So hope that you got that what is linear equations, what are non-linear equations, what is linear equation regression, and what is non-linear regression, and what is a linear system and what is non-linear system. Fine. Now the question is that when to choose linear regression, when to choose non-linear regression. We will discuss about this after this slide. Okay. So regression analysis with MATLAB. There are certain functions in MATLAB, certain modules are available for regression analysis. Let's discuss about that, how you can use MATLAB for regression analysis. Okay. So curve fitting toolbox. There is a curve fitting toolbox in MATLAB. It is used for linear and non-linear regression both, and for maximum 3 variables only. So means you can use 1 dependent variable and 2 independent variable in curve fitting. Basics MATLAB. If you are using basic MATLAB, there you can only use a linear regression model. You can create a linear regression model for polynomial fitting in basic MATLAB. Now there is another toolbox, that is statistics and machine learning toolbox. It is used for various fit. You can use linear, you can use non-linear regression, you can use stepwise linear, Rees and Lasso regression. So in this webinar we are going to see stepwise linear, Rees and Lasso regression. And apart from that, there is a machine learning where we use regression. Okay. In MATLAB there is a deep learning toolbox. You can design neural network also using deep learning. That there also we use regression analysis. Okay. Further, there are more 2 toolboxes. Let's say if you have to optimize some parameters based on any objective function, you can use optimization toolbox and global optimization toolbox. So this both are also used for regression analysis. These are some toolboxes which I discussed that you can use MATLAB for regression analysis. Okay. So fitting a regression model, how it works. You see here, this is a response y is equal to, and you will have multiple predictors. Let's say in this case we have 2 predictors, that is x1 and x2. Predictors are also called inputs. And what is the response? Only one response we have, that is y. So it takes the summation of all variance. Variance is what? The equation can be ax1 plus ax2. Or your equation can be ax1 plus ax2 plus cx1 into x2. Different kind of variations are there. That is a summation that will be your output. That is will be your response. So there can be a multiple sub functions in the response. Or it can be only ax1 only. Maybe x2 is the redundant. So how to remove the redundant, how to identify redundant predictors which we don't require. Let's say you have some patient data, and if I am saying that patient is normal or abnormal heartbeat of patients, it is normal heartbeat or abnormal heartbeat. So what can be a redundant predictor there? Indexing. Patient number 1, patient number 2, patient number 3. That is a redundant because we don't require that input to create our mathematical model. Now if I am saying if you have 200 or more than that or 100 predictors are available there. So manually identifying that which predictor is not responsible to create your model, it will be very complicated to do. So that things I am going to show you how you can automate all that process. Okay. Now equation representation in MATLAB, that is also very important. Let's say if you have to represent some kind of specific equation, then how you can represent that equation in MATLAB. See, first y, this sign x1 plus x2, what it means, y is equal to c0 plus c1 x1 plus c2 x. Here c0, c1 and c2 are regression coefficients, or you may say model parameters, right? So if you want this kind of equation, and when you are fitting, you have to provide like this, and you will get the output like this. So in this case we are adding the terms. Plus sign is I am adding the term. Now let's say if you don't want coefficients in your equations, I mean constant if you don't want, we use minus sign. Here you see y is equal to this sign shows the equality. Y is equal to x1 plus x2 minus 1. What it means minus 1? That we don't want that constant. So your equation will become like this. Y is equal to c1 x1 plus c2 x2. Asterisk sign is used for multiplication. If I am writing this, I want this kind of equation, that it will be a multiplication of x1 and x2. So your final equation will look like this. Y is equal to some constant, because we didn't exclude that coefficient in this case, right? Plus c1 x1 plus c2 x2 plus c3 x1 x2. Or you can use this also use the product term. Let's say that if you don't want product term, so you can exclude that product term, or if you want just only product term only, so your equation will be like this. Means you are emphasizing that you want just a product term of by both input. So in this case you are going to use this sign, okay? And this cap is used for the power. Simply I want any equation in the form of x1 square plus x2 square, so I will write like this, and my output will be here, because we didn't exclude anything. So we are getting the x1 terms also, x2 terms also, we are getting this. If you have to exclude, then what will you use? Minus. And what term are you going to exclude it? But if you are emphasizing that you want multiplication or division of variables, in that case you will use column. Fine. Okay, I am going to switch to next slide. Now about stepwise linear regression. Before stepwise, let me show you a simple fitting example how we can generate a mathematical equation for your data using a polyfit. Okay, just I am switching in MATLAB. Here is my MATLAB. Okay, let's say I have data here. Let me open from outside of MATLAB. This is my data. We have one input column and second is the output column. I want to generate a mathematical equation for that, as well as I want to densify this data. Right now we have only 10 samples. I want to make it 100, 200, 500. How we can densify this data using the basic MATLAB. Okay, so my first step is to read this data. My data to read as a table. Yesterday you saw that if you want to read table, then how you can use, right? Read table and your Excel file name, that is a sample demo.xls. Okay, so now we have my data as a table. If I click here my data, you will see that this table is imported in MATLAB, and we have two variables, x as a predictor, y as a output. Okay, now we are going to create a mathematical equation just using a polyfit. So first of all, we have to extract the input. So x is equal to, I will use my data dot x. So x will be, here I have to use semicolon. So x I have. Now what is y? Here I will replace, x will be replaced by y. Okay, now we have x and y. Now I am going to create a model. So here I am going to use my poly model, okay, equal to, as I told, I am going to use polyfit. Polyfit is used for polynomial fitting. Okay, input, what is predictor and what is output, that is y comma, and degree of polynomial. Let's say I want a polynomial equation of third degree. So it's not like that. If I am providing a third degree, always I will get a third degree of polynomial equation. It depends that what is the best fit. Based on that I will get the output. So when I provide this, I will get some coefficient. So what it shows, this is a coefficient of x square, this is a coefficient of this is a coefficient of x cube, that is 0, this is a coefficient of x square, that is 1, coefficient of x is 0, and constant is also 0 in my case. Now I want to predict a new data or densify my data. So in this case, what we can do here, I am going to predict and I am going to save it as a ypred. Okay. We use polyval, means polynomial values on my model. So polyval, and what is my model? Model is poly model. I want to predict from 0 to, and step size I am going to give 0.1 and 20 value total. Okay. So what it means, this is my new x. It will start from 0 into 20, and this step size is 0.1, means first value is 0, then 0.1, 0.2, 0.3 till 20. So I will get the output on that, right? So if here, this is my predicted output, and my data is also densified in this case, right? We had only 10 values, now we have lots of around 201, right? If I plot x comma y, this is a simple plot, the data which I had that is the observed data plot, and predicted also I want to plot it. Just simply I will give a command hold on, then plot. What will be input? X-axis, this data, and what is the output? That is ypred, right? Ypred, and I want to predict it as a circle and in red color. So this is a marker color and marker type both. As a circle marker I want and red color I want. Sorry, there is some mistake. So the mistake was here that I used dot, we have to use comma here. So whenever you have error in any place, MATLAB will let you know that there is a error. Okay, and don't forget to give a command hold off also. Now you see that this is my graph. So here we have a both graph. If I zoom this, let me zoom this one. See, the blue one which you see, that was the original measured data or observed data, and the red circle which you see, that is a predicted. So it is a perfect fit for my data which I had. That is the basic which I told you. If you have to densify your data, then you can use polyfit for you. Okay. So what functions we use? In this case, to fit our data, we use polyfit. To execute our data or to predict data on the model, we use polyval in this case. Fine. Switching here. Now, what I want to say, let's say that for x1, x2, x3, you have multiple equations. Of course, we can get multiple equations. Choice of equation, that which equation will be a best. Your equation can be a linear, or it can be a non-linear this kind, or it can be a third degree polynomial, or it can be all squares. So how we are going to choose that which equation will be a best? So in this case, we can use stepwise linear regression. So in this topic, you are going to learn stepwise LM, that is the inbuilt function in MATLAB, how we can use this function to choose the best equation for your data. Okay, and the data which I have this. So there are two cases which you are going to use in this topic. So first is find a best fit for mileage. First of all, the data which I have, that is car data. I have a car mileage data, car acceleration data, car weight data. Okay, so find a best fit for mileage with respect to acceleration and weight. So in this case, mileage is the output acceleration and weight are inputs or predictors. So what kind of equations we can create in this case? Maybe weight is redundant, so my mileage will be with respect to acceleration. If acceleration is redundant, then mileage can be with respect to weight. Or mileage can be with respect to weight and acceleration plus constant. So in this case, many kind of equations can be. It can be a weight plus acceleration plus constant, or it can be weight plus acceleration plus weight into acceleration plus constant. Multiple equations we can create, but we don't know which will be a best fit. That we are going to see how we can do. Okay. So first of all, I am talking about this stepwise LM. Let's see that what is this. This is a stepwise linear regression. Okay. If I am going to open a doc of it, it will open a document. So it is a stepwise linear model. Stepwise linear model means stepwise linear regression. What kind of properties are available here? See here. If you have categorical predictors, you have to mention that what predictors are categorical. So stepwise linear regression is not used only for numeric data. You can use for categorical data also. So you can provide categorical data like this, category words and which columns are categorical, like this way. Okay. Now criteria. What is criteria here? So what is the criteria that you are choosing that which mathematical equation will be your best? Let's say I have 10 equations. I have to provide some kind of criteria. It will compare with that criteria and it will select that this mathematical equation will be a best. Let's say I am providing MSC, mean square error. So it will compare with the threshold value of MSC and it will select that do I have to choose that equation or we have to remove that equation. So there are different criteria like SSC, AIC, BIC, R squared value, adjusted. Depends on you that what criteria are you going to choose to compare all equations. Okay. Exclude. If you want to exclude any predictor, you can provide this property. Exclude and the column name. Like here, exclude second column and third column I don't want. So we can exclude that column. Okay. More parameters. Intercept. What is intercept? That constant. You don't want intercept, you don't want constant, then you can provide property intercept false. And this is very important. Lower and upper. What lower means that what will be from which equation it will start. Let's say I am starting from constant to third degree of polynomial. So it will start from the constant, then it will create equation for first degree, second degree, then third degree. It will compare with all and you will get the final output whose will be a best fit, which will be a best fit, you may say. So lower you can provide as a constant or you can provide as a linear, that it will start from the linear equation. Same as it is, you can provide on upper also. Okay. There are some more properties are available here, so you can go through that. What are predictor variables? That also you can provide. Okay. What you have to remove? We use p remove. Some components, if you want to remove it, you can provide, and you can provide the threshold value. If it is above that, it will be removed. If it is below that, then it will be there in your equation. So lots of properties are available there. Okay. Now I am switching here in MATLAB and I am going to open that stepwise linear regression. So first step is I am going to load that data. So before loading, let me give a clear and CLC command. If something is some variables, if there are, then it can be removed. So I loaded that data and let me show you in workspace what kind of data I have. You can see that we have acceleration, cylinders, displacement data of vehicle, horsepower, model number, model year, all this data we have here. Fine. Switching here. Now I am going to plot. Mileage is output. In this case, mileage is output and acceleration and weight are predictors in this case. So I am going to plot acceleration with respect to mileage. Let's see what graph is there. And further, I am going to plot mileage with respect to weight of the car. Okay, we have that graph also. And here marker type I choose red circle type. Okay. Next I am going to plot mileage with respect to acceleration and weight, that is a 3D. So in this case I use scatter 3. Acceleration will be on x-axis, weight will be on y-axis and mileage will be on z-axis. By this graph you can find out the correlation between predictors and outputs. You see in this case on x-axis we have acceleration and mileage is output. When I am increasing or decreasing acceleration, how your mileage is varying. So by this figure you can say acceleration is not so much dependent. But in my case I had only 3 predictors, so I was able to visualize and remove them. So in this case I can remove acceleration. But what if I have predictors more than 100? So manually it will be very complicated. That's why we are going to use stepwise linear regression in that case. Second graph which you see, mileage with respect to weight. So you see that when I am increasing the weight on my car, mileage is decreasing. So in this case you may say weight is the input and weight is highly dependent on the output, that is mileage. So we require this mileage predictor to create a mathematical equation. Third one is mileage with respect to weight and acceleration. So in 3D plot, we are not able to say that how mileage is related with weight and acceleration. So it is very complicated to do this task, right? So again, that's why we are going to use stepwise linear regression. Okay. Next, here, first step is what I am doing. Both predictors I am putting in a single matrix. So when to concatenate two variables we use a square bracket. So here you see if I run this one, so my first column will become acceleration and second column will become weight. Okay, these are predictors and my output is mileage. Okay, now here we are creating the upper limit, means upper equation, and lower. So t starting is a lower one. First column shows x1, second x2 and third constants. In this case you see that all three are 0 0 0. It means my first equation it will start from constant. Then next, let me run this first of all, then I will show you. So how we are creating that, how many equations are we going to create and with how many equations it is going to compare. So in this case this is the start, that from constant it will start to creating a mathematical equation. Then upper, it will you choose this one also constant, or it will choose with respect to acceleration only, because in this case weight is 0 and constant is also 0, or it can choose weight only, means my equation can be this one with respect to acceleration, or my equation can be with respect to weight, or my equation can be with respect to weight and acceleration both. So we created the lower and we created the upper bound here, that of equation. Okay, now we are going to use stepwise LM to find out the best fit. So here you see stepwise LM, X is input, means predictors, you can have multiple predictors. Mileage is what? Output. T starting, that is a matrix which we created, this one. This is the lower one, and what is the upper? This is the property value. What is the upper? T upper, this. So it will compare with these four equations. Verbose to, it means that you want to display iterations also. So verbose to, if you don't provide verbose to, then it will not display the iterations. I am going to run and I want to check my equation. So here you see, these are the properties here. You see that acceleration is excluded. My equation is y is equal to some coefficients, some constants plus acceleration with some coefficients. And what are the intercept? That is constant, that is 49.238 it is estimated. And what is the coefficient of weight? That is minus 0.0086119. And you see that acceleration is removed from here because we don't require that acceleration value, because you see that in this graph it is not so much highly dependent. That's why we remove that acceleration. Means this model automatically removes that acceleration. Now you see, as we saw that we don't require acceleration, but still you have to provide two inputs to predict. Let me show you. I am going to switch here in MATLAB. This is my model. To predict on new data, we use command predict. Okay, predict. Then my model, and here we are going to provide two inputs. First input is acceleration. Let's say it is 40, and weight is, let's say, 4000. And I want to predict what will be a mileage of my car on these two inputs. I got this 14.7899, but I said acceleration is removed. So you see here, when I change this acceleration value, instead of 40 I am going to provide 60. Still my mileage will be the same, because my equation is not dependent on acceleration. My output is not dependent on acceleration. So you change the value of acceleration, there will be no effect on your mathematical equation. Let's say I am going to provide 100, no effect, same value. Now my equation is dependent on weight. Let's say I am going to provide 3000, and you see that mileage is changed. This is the proof that which we are showing, that my mathematical model is not dependent on the acceleration, but it is dependent on the weight only. So when I am changing the weight, then my output is also changing, and when I am changing acceleration, then my output is not changing in this case. Fine. Next, if I have categorical data, let me show you something here, model here. So the model of cars which we have here of 3 years, 70 means 90-70 models we have. Further, if I go below, we have models of 76 also, and we have car models of 82 also. Okay, so why these are categorical data? This is very important, because when I give input as a 70, it is fine, but we can't give 70.5 or 76.5 or something like that, because these are fixed value. If you have a fixed value which you cannot change, you have to convert it as a category. So Stepwise is supported for categorical data also. Instead of 70, 80, you can write some characters also, like yes, no, big, high, low, like this also. So what we have to do, these are fixed value that I have model of 70, 76 and 82. Okay, so we have to convert as a category before creating a predictive model on that. Now further, if I provide 76 model value, that a model of 76, if I provide 76, then it will predict the mileage of 76 model cars. If I provide 82, it will predict mileage of 82 model cars. So I want to create such kind of predictive model in this case. Again I am switching here. So here second is stepwise regression with categorical data. To convert your fixed value as a category, we use this command. So we have this model here as a fixed values, we are converting as a category, and we are saving it as a year. So see here, if I do whose model year, and further here if I do whose year. Okay, now I am going to run this. You see that before model year it was as a double. Now I converted this as a category and saved as year. So class became categorical, right? Okay. After creating this as a category, we are creating a table of it. So you see that mileage is my output, that is the response of the system of my car. Weight is a predictor and year is also predictor. When I run again, so what will I get? I will get a table as a TBL1. So see here, if I move my cursor, so it is showing you as a table, right? First is output, first column is output, and remaining both are predictors as a table. Fine. Now to use a stepwise linear regression, simple command is here, stepwise lm. This is my table, and here you see I assigned the mathematical equation, that what kind of mathematical equation I want. But in this case, this shows that it will start from weight, then it will go for acceleration and model year also. So I am starting from weight, so mpg is equal to weight. This is my lower value, and upper will be polynomial of 2 degree and 1 degree. So how many kind of equations can be in this case? Your equation can be weight square plus year plus weight, or your equation can be weight plus year plus weight into year. So multiple kind of equation can be created again. So if I use this function, it will choose a best fit. As a default, I told that it choose the criteria. As a default, it use p-value. If p-value is lower, then that term will be added. If p-value is higher than, if p-value is higher than threshold value, it will be excluded. Okay, I am going to run this model. Now you see here, 2 times it is executed. See here, this is my equation. Mileage is equal to some constant plus some coefficients into weight plus some coefficient into year plus some coefficient into weight square. So my final means upper, which I provided polynomial of degree 2 and 1. Here you see it is a degree 2, but it excluded one term, weight into year in this case. Why? Here you see weight into year, this is the p value 0.007, and weight square p values, you see that is this one 0.0022. So this value is very low if I compare with the threshold value. As a default, threshold value is 0.005, that's why it is excluded from there. Okay, and these are the weight parameter. This is the weight coefficient, and this is the year 76 coefficient, this is the year 82 coefficients which we have, right? So I have model here as a MDL. Now if you want to predict, what you have to do? You have to provide predict, then your model name, so it is model 1, and here you have to provide 3 inputs. What 3 inputs will be? It will be weight and year, 2 inputs, weight and year, right? Weights and year. So let's say that weight I have 400, and year we want to provide as a categorical, right? Categorical, let's say 76, bracket close, enter. So here we got the error. The reason is that because here you see what was the reason here actually, just wait a minute. Here we have to provide input as a table, and what I did here, I provided input as a matrix, and in a single matrix you can't say numeric value also as a categorical value also. So instead of that, the table which we created here, what we can do, just we can choose any one from here, just you can this to one, right? You can save it as a table, as a new table, and this if I provide as an input, it will predict that what will be a mileage on that. So if your input is as a table, then you have to provide input as a table in your model as well. Okay, next one. we can create a dummy variable also, because let me show you one thing here. This is my year. Sorry, just wait a minute. This is my year, right? Or if I open this year, these are categorical data: 70, 76, 82. Let's say I don't want to use this 70. I don't want to use a model of my car of 70. I don't want to use. So in that case, what we can do, we can create dummy variable. The function is dummy var of this year. When I run this, you will see here what it is created here actually. See, if there are these are binary. If value is 1 in first column, means it is a model of 70. Okay. If I go more below, this is a model of 76. If last column is 1 and remaining are 0, then this model is of 86 or 82, whatever was there. So what I want to say, if you are using neural network, you cannot provide a categorical data as an output. So if you have multiple outputs, you can create a dummy variable of that. So that's what I am doing here. I am creating a dummy variable in this case. So here you see, this was my model. So first of all, what we did here, first of all, I created a dummy of this year. So we'll get the 3 column, right? And further, I extracted of 76 here, means second column. See here, all rows second column, and 82 year data third column. So here you see I am not using 70, right? So now in this case, what inputs we have? Year 76, year 82, and we have weight, and mileage is the output. So we are creating as a table again, and we applied stepwise, and the equation will be like this. It will start from weight, and upper is polynomial with 2 degree, 1 degree and 1 degree. So you see here, same as it is, this equation is created. 1 plus car model of 76 plus weight into year, that is 82, right? So hope you got that how to exclude the redundant predictors using the stepwise regression, and how to create a mathematical equation for that, and how we can compare multiple equations of different kind, like it start from the constant and it will go till order degree number 5 or 6 or 10 or 20. So in this case, it is comparing with all kind of variations, and it is giving you a best fit. And this is my model, and you can use this model for the prediction. So what we have to provide, input you have to provide the model number, means model year, that is of 80, 82 or 76, right? And we have to provide input as a weight, and it will predict for you. Okay. So right now, let me summarize that what we did till now. So first of all, we understand what is a linear and non-linear models. We also understand that what are linear and non-linear systems. Also we saw that what kind of equations are linear and non-linear. Also we saw that if my model is linear, it doesn't mean that my regression will be linear, and it doesn't mean that my equation will be linear. It can be non-linear also, right? And we use two kind of things. If I have categorical data, then how we can use stepwise linear regression, and if I have non-categorical data, then how we can use stepwise linear regression again. So two cases we choose. So now if you have categorical data or numeric data, you can use stepwise linear regression in both cases. Fine. Now we are going for the next. Now we are going to use Rees and Lasso. So Rees and Lasso, why I am going to use this both algorithm Rees and Lasso? Using this, you can compare with thousands of equations. Previously, what we did, we are comparing with 5 kind of variable. In this case, you can compare thousands of equations, and which equation will be a best you can identify. So this is a Rees and Lasso equation. It will look like this. What we do, Rees in this kind of linear regression, the coefficients are chosen by minimizing the mean square error. Means what coefficients we require, what coefficients we don't require, it compare with mean square error of all the terms. So mean square error is the square difference between the observed and the predicted response value. So of course your equation will looks like this. This is a predicted response and this is the original response, just minus the mean square error, minus these terms, and we will get the mean square error. So whatever the minimum square error will be in comparison of different variants, the minimum will be chosen in this case. Now this equation is common for Rees and Lasso both. So what is difference between them? Here you see in this term, penalty term is added here, lambda is added here, here also lambda and penalty term. In Rees regression, this C value which you see, that will be square, but in Lasso it will be not square. So here you see, in Rees and Lasso regression, a penalty term is added to MSC. This is MSC and this is a penalty term. Also it says this penalty term is composed of the fit coefficients values and fit coefficients value. These are the coefficients values C which you see. And the tuning parameter lambda. The larger the value of lambda, the greater the penalty, and therefore the more the coefficients are shrunk towards 0. What it means, that the larger the value of lambda, the penalty will increase also. When we increase the lambda value, maybe some predictors will be removed from there. That is the penalty. Maybe that I require that predictor for my model, still it is removed. That is the penalty actually. So, and what is the lambda? Lambda shows that how many mathematical equation you want. So if you increase the mathematical equations, you will get the higher penalty. So here you see it is squares. In Rees you are getting the more penalty. In this case you are getting the less penalty. Okay. So this is the Rees regression and Lasso regression. So we have the same data and we are going to apply on the same data, Rees and Lasso both. Okay. So let me show you how to use this. I am switching here and I am closing everything if something is open, and I am going to clear my command window. And let's start Rees and Lasso, how you can apply on multiple equations, thousands of equations, hundreds of equations, or more than that. Okay. So it's still opening. Just wait a minute. Let me close this. I don't require. I think MATLAB is open since morning, so it is hanged here. Just wait a minute. Okay, let me off the MATLAB and open it again. Some issues occurred here. Just wait a minute. Meanwhile, if you have any questions or query, you can write in a chat box. I will reply it. Okay. Let me open that MATLAB again. Okay, if you have any questions or query, you can ask me here in chat box. Anyone? Anybody has any question? Whatever I told till now? Okay, I don't think that anyone have any questions. So it means there can be a two reason. That first reason is that you got everything. second reason is that nothing you got, to hope that first reason is correct, that you got everything right. So sometimes it happens because of window, if you are using it, maybe because of firewall or some other reasons, you can get this kind of issue. Not only with MATLAB, any kind of software if you use, you can face this kind of issues on that. Okay, so it is still taking little time. So when you open again, then it takes 1 minute around to settle down everything. And later if we will see optimization also, that what is optimization and how we can utilize the optimization techniques also. Okay, so in optimization I am going to show you a linear optimization. It is a very good example which I am going to take, but before that let's see that how Rees and Lasso work actually. So first of all, you see what I am doing here. I am taking predictors as an acceleration, cylinders value, displacement value and weight. So in this case, I don't know which input I have to exclude or which predictor I have to exclude from that. So I am taking all whatever I have. If I had more than 4, I could take more than 4 also. So I am concatenating it in a single matrix. This is my first step which I am going to do. Second step, to identify if there are missing data or not in this. So what we can do in this case, let me show you something here. In car data, if I have any is missing values, simply what we can do is missing command, and let's say if I want to check if I have missing value in mileage or not. Okay, and further if I have missing value, it will give me value 1, so I am going to sum of it. If I sum of that one value, it will tell me how many total number of missing values are there. So in my list there are 6 missing values. If you have missing value, you cannot apply the Lasso or Rees algorithm on that. Okay, so total number of 6 missing values I have. So how to remove this missing value? I use simply a fill missing. But let's say if you don't know that how to remove that missing value, what you can do in live script, just go here in insert. From insert you can use this kind of pre-processing like clean missing, remove trends and smooth data. In my case I am going to use clean missing. Okay, and further here you can provide the variable where you have a missing values. So in this case, in mileage we saw that we had a missing value, right? And what kind of are you going to fill that missing data or you are going to remove that missing data? You can choose it from here. And what kind of algorithms are you going to apply on it? Let's say I am going to apply spline interpolation. And here you see that the dot red we choose that were missing data that are filled. Now we don't have missing data. And here you can provide output that where are you going to save it. And further you can convert this as a editable code. So in this case I don't want all these plots. I just want this output. Fill missing, mileage, and what algorithm I am going to use that fill. Same thing I did here. I filled that missing value. Now I am going to divide my data for training and testing. Because when you are going to apply Lasso or Rees, we have to apply on new data. Okay. So here you see we use CV partition for dividing your data for training and testing. So what I am doing, I am dividing this mileage for the training and testing, hold out 0.3. It means 30% data will be used for testing and remaining 70% data will be used for training. So CV partition, and further based on this I am extracting training inputs, the data which I have to train inputs, and based on this I am extracting the output, that is mileage MPC. Okay. for the training, and I want data for the testing. I am using not sign. So in MATLAB, this sign is assigned as a not. So not training. So here I will get the input as a testing, and on every input I will get the y test, that is the output, that is the mileage. Okay. Now we splitted our data for training and testing. Fine. Next is this, the lambda value defined, which I was talking about. So I want 301 mathematical equations and I want to compare that. So you can define in a lambda. So here you see that it will start from the 0 until 300, to total counts will be 301. I am going to use this reach inbuilt function. This is my input. What are inputs? Let me show you again what are inputs in our case. Acceleration, cylinders values, displacement and weight. Okay, four inputs we have as a y train, and what is x train, that is mileage. Okay, and further this lambda r which we created here, lambda value and 0 value. If I don't give 0, it will be rescaled. My br is what? Br is the coefficients. If I don't provide 0, it will be rescaled between 0 to 1. That's why I provided here 0 value, so it will not rescale that data. Original coefficients I will get. So total how many equations I will get? 301. So let's say I am going to run this, and after execution you see that what is the matrix size? 5 into 301. So this one column shows us first equation. This first row shows coefficients for every equation. Okay, so 4 predictors we had. Okay, 4 predictors we had and 4 coefficients we got plus constant value. Second equation can be this, third equation can be this, fourth equation can be this. Total number of 301 equations are generated. Okay, so now we have to identify which equation will be a best. So for that it is very simple. What I am doing, I extracted the coefficients, I extracted the constant, first row, all first row plus x takes into this matrix multiplication. So how many equations we will get? 301 equation we will get for all 30 samples. Okay, if I run this, check. So it is still executing. Let me execute it again, and you see here first column is showing first equation, this is showing second one, and in first equation we had 30 inputs, 30 samples. On 30 samples these are the output for first equation. For 30 samples, these are the output for 30 samples for the second equation, and these are the output for 30 samples on third equation. Like this we have 301 equations. So how to compare that and identify the best fit? Very simple. Simply calculate the mean square error predicted, whatever predicted I have here as a matrix, minus the original one from every column, take the mean value. Let me run this first, then we will discuss about it. So in this case I took the mean. So what it did, what is the output here? Of every column we got the mean square error, and further if I give mean of this, I will get the minimum mean square error here, and the what is the index number 1. So in this case in BR this first is perfect if I compare with other equations, right? So again I am repeating, we are calculating the mean square error. So mean square error is the square of the error. So first of all we calculated the error, and first the mean of this error is square. So I will get mean square error here of every column, and further I want to identify which is the minimum mean square error. So mean of that row, I will get the minimum value and the index of it. Okay, and further I am plotting mean square error with respect to lambda. As I told that you have to pay high cost. For that, you see that when lambda is increasing, then my mean square error is also increasing in this case. And further, how many coefficients are removed from there? Either cylinder is removed, either acceleration is removed. Let's check by this. If n is removed, then number of non-zero values b is equal to 0. So wherever this condition will satisfy, I will get value 1, else I will get 0, and total I am counting. So here you see all 4 coefficients we have, and no predictor is removed from here. All predictors are responsible in this case. Okay, this is the first way to do. Okay, second way is Lasso model. So one thing remember, in Lasso model we have to normalize our lambda value by the total number of samples, first of all. Second thing, in this case the constant value we get it as a fit info in Lasso, and coefficients value you will get here as a BL. So when I run this, I will get here BL as a four inputs we had, so 4 coefficients we got column wise, right? And here we'll get the intercept. These intercepts are what? Constant values. Total 301. Now to create a mathematical equation and predict on all data, very simple. Add this constant as a row, fit info dot intercept plus testing data which we saved, multiply with all coefficients, right? So when you run this, you see in this case the best fit is at index number 46. So here if I go in BL, 46 the column number which is, that is the best mathematical equation for my data. Okay, and this is the plot with respect to lambda. Sorry, just 1 minute. This is the plot with respect to lambda, means mean square error with respect to lambda. So this is the way how you can create multiple mathematical linear equations and you can compare using mean square error. So it is very simple. Math is used, that's all and nothing more here. Okay. Next thing, you will have one question here. Just wait a minute. You will have one question that the equation which I created, that was a1 ax1 plus bx2 plus x3, that is a linear equation. What if you want a non-linear equation? So you have to modify in the matrix to get that non-linear equation. Let me show you, it is still opening. Okay, how it works. Okay, let's say I have matrix is equal to acceleration and weight. If I use this matrix, I am getting the linear equation in the case of Lasso and Rizz, right? I want my equation will be something like that: acceleration plus weight plus acceleration into weight. So what you have to do, you add here just one more column, acceleration into weight. So now your equation will become non-linear. So in this case, we saw in stepwise linear regression, we were able to assign the equation directly by using notation. Which notation? This one. This kind of notation, right? But in this case, you have to change in a matrix that I want the equation like this: acceleration, it will be in terms of acceleration, my equation will be in the terms of weight, and my equation will be in the terms of acceleration into weight. So just modify your matrix like this and you will get a equation in such a way. Okay, we saw that which equation will be a based, and further we saw that which redundant predictors we don't require. So we saw both way. We saw stepwise linear regression, we saw Lasso model, we saw Rizz model also. So if you have any doubt or any questions, you can write in the chat box. I will clarify that. Now further I am going to switch here, and one more demo I will show you, that the basics of overview on optimization and global optimization. Why? Because we use regression or we create a mathematical equation in optimization and global optimization as well. Okay, so what is the optimization? Optimization is an iterative process by which a desired solution, means it can be, solution will be a maximum or minimum of the problem, can be found while satisfying all its constraints or bounded conditions. So let's say that I have this curve here. Just wait a minute. This curve which you saw, if you have to optimize this, so we will have a two kind of solutions, either maxima or minima, or global maxima or global minima. Okay, so depends on you, are you going for maxima or minima, or are you going for global maxima and minima? So the main objective of optimization and global optimization is to extract the maxima or minima. Okay, this is the optimization. And why didn't the solver find the smallest minimum? In generally, means what is the reason that any kind of solver is not able to find the local global maxima or minima? In general, solvers return a local minimum. The results might be a global minimum. It can be a global minimum, but there is no guarantee that it can be a global minimum or global maximum. A local minimum of a function is a point. See, I am talking about local minimum. A local minimum of a function is a point where the function value is smaller than at nearby points. That is the reason. Let's say that I have to find out the local minima, or I have to find out global minima, but my starting point is somewhere here. It will identify this minima, not this one. But if my starting point is here, then it will identify the global minima. So depends that what constraints are you going to give, what boundary conditions are you going to give, and what start points are you going to give. Based on that, it will identify where is the local minima or global minima or global maxima or global minima. Okay. So generally in optimization toolbox in MATLAB which is available, it is used to find out the local maxima and minima. In MATLAB there is a global optimization toolbox where advanced algorithms are there like particle swarm, genetic algorithms, some other kind of algorithms are also available. So if I have to find out the global maxima approximately, not the exact, because there is no guarantee that it will find out the exact global maxima or minima, then in that case you are going to use global optimization toolbox for that. Okay, fine. So what is basin of attraction? Basin of attractions are boundary conditions, constraints. Let's say this is one dimensional basins will look like this. Let's say that your boundary condition is between this and this, so it will always find out minima from this one. But if your boundary condition will exceed this line, then your global minima will be in this region. This is a one dimensional. Several basins also of attraction also you can be here, that is a 2D, so it will look like this, or one basin of attraction with multiple starting points also you can provide. Not only one, multiple starting points you can assign to find out the minima or maxima. And or you can modify this with constraints like that y will be smaller than equal to x, or y is greater than equal to 5 minus 4, some equations that are constraints which we say, that is a inequalities in this case, right? Linear inequalities is this case, right? So using optimization toolbox in MATLAB, what kind of problems you can solve? Nonlinear optimization, linear programming and mixed integer linear programming, quadratic programming, least squares, system of nonlinear equations also you can solve. And these things are two types: problem based optimization and second is solver based optimization. So choice is yours, you are going to use problem based or solver based. I will show you problem based one demo. It will just, I will take 10 minutes more because time is already we have 10 minutes. Okay, so two way you can optimize your objective function. You can choose problem based or solver based. In global optimization, we have different kind of algorithm like pattern search, genetic algorithm, particle swarm, surrogate, simulant enablement, multi-objective Pareto search. This kind of algorithms are available in global optimization. So I am going to show you problem based first of all. So in problem based, it is easier to create and debug, but problem based is used only for linear or quadratic problems or mixed integer types also. Okay. So the problem based approach currently applies to linear programming problems, mixed integer as I told, or you can use for quadratic programming problems or linear least square problems also you can use using problem based optimization. Okay. Solver based represent the objective and constraints as a functions or matrices. So let me explain what is solver based and how it works. So you see here, let's say this is my objective function. If you are using solver base, let's say this is an objective function and you want to optimize this, and for this objective function you have some constraints here, upper bound and lower bounds are also given. So what we do in this case, we create a matrix like in this case for this linear inequality, a matrix will be 1 because coefficient of x1 is 1, then again 1 because coefficient of x2 is 1, then semicolon means second row, that will be 0.25 and 0.25. Same, we create a matrix for x1 x2, that is a lower bound 50 semicolon 25 means single column, and for the upper bound also single column. So this x1 x2, these are upper bounds and these are lower bound. We provide this matrix as the input like this, len proc, this will be your function, this, and a left side of inequality, b right side of inequality, a if you have equality also, you will provide the matrix of equality of left side, right side, matrix of lower bound and upper bound. But in our case, we are going to show you linear. So in linear, what things we are going to do here? A chemical plant we are going to optimize. In a chemical, if I am talking about chemical plant, of course there will be some chemicals. So there are around 16 chemical values, and using that 16 chemical values we are creating a one product based on the chemical. So what I want to optimize here, I want to optimize that what will be a optimized chemical values, so my cost will be minimum. What is the cost equation? This is the cost equation. So I have around 16 chemical values. We are mixing that chemical values. We are creating a product. And what is our goal? To optimize, we have to find out the optimized value of all chemical values. So my cost of plant will be minimum. And these are the steps which you are going to follow. Get an overall idea of the problem. Identify the goal. Identify the variables which we are going to use, constraints mean linear equalities or linear equalities, inequalities or equalities. So then determine which variables you can control, means which variable is more sensible, specify all quantities as a mathematical notation and check the model further. Okay, these are process we are going to follow. I am switching here and I am going to open that model which I am talking about. Okay, so I am going to choose problem based. Here this is a price value, means this is the objective function which we have to optimize. In this case we have some constraints also. Let's say that there is one chemical that is P1, and the chemical value which I have, the limit which I have, minimum I can use this much of this chemical and maximum I can use this much. Let's say one more chemical I have, that is I1. Minimum is no bound, but maximum I can use only this much chemical only. For this we have linear equalities and equalities. Inequalities and equalities we have here. So first of all, whatever your chemical variables are there, means whatever chemicals are you going to mix, you have to create symbols for that. So we use optimvar. See, P1 is my first chemical, optimvar. This is the symbol for that P1, and this is the lower bound of it, what minimum chemical I can use for P1 and what maximum value I can use for P1, lower bound, upper bound. Just you have to create all like this, whatever variables you have. In my case I have around 60 variables. Okay, in your case maybe it can be 4 or 5 variables only. Okay, so after defining this, we have to create a problem. Means what is my objective function? So simply we use optim problem and objective. This is a property name and this is my objective function. So first of all let me run this one. Okay, so now we have this objective problem also. Next step is to apply inequalities and equalities. First of all we are going to apply inequalities. So as it is we have to write it. See, lean prop is my structure, or you may say it is an object where I created this problem which I have to minimize. Using this lean prop as a structure, we can define linear and non-linear inequalities also. Okay, so here you see lean prop dot constants, constant 1, this is the as it is inequality equation. Second is this one, inequalities, and I saved this. So in our case we had 3 inequalities only, we assigned it where in this object, and from where we created this object, from here. Okay, next equalities, same way we create a equalities also like this. So I am going to run this. First of all let me run this one, and second this one. So what we did, we created the variables, we created the chemicals as a symbols, and further we assigned problem means objective function which we have to optimize, and further we created a inequalities and equalities also. To now everything is done, we have to solve this. So simply we use the solve command, and this is my objective which I have to solve. Here everything is defined by all chemicals, variables, and my objective functions are also defined in this structure, as well as equalities and inequalities both are defined. If I give this solve command, I will get the solution bit. It will tell me what is the minimum value for that. So you see here, this is the output. Let me it is still executing, and here you see that these are the outputs. Means my first chemical, the value will be 0, second chemical value will be 0, third chemical which I mix, the optimized value is 8.1697 into 10 to the power 3. So all 16 chemicals are executed and they are optimized. On these values, the minimum price of my plant will be 1.2703 into 10 to the power 3. That is the solution. To execute the solution, we use evaluate, and these are my objectives, lean prop, and this is the solution. It will be executed and you will get the price like this. So that's all. This was about the session of today, and if you have any questions you can ask me. And further already Zafar sir discussed that if you want to learn MATLAB, if you are a beginner, you can go for the MATLAB on RAM, machine learning on RAM, deep learning on RAM. That courses are free and you can go for that, and you will get a certificate also for that as well like this. Okay, so please ask if you have any questions. We can discuss about that questions, whatever questions you have.